This is the X-59 Quest, a new plane built by Lockheed Martin for NASA. NASA is hoping it will be able to solve a problem that has stopped commercial airplanes from flying really fast. That's because
when an aircraft goes supersonic, faster than the speed of sound, it creates shock waves.
When I heard a sonic boom for the first time, I finally understood why it was such a big deal. If something's traveling supersonically, you can see it coming, but you won't hear it at all until it's already past you.
As you can imagine, sonic booms can be disruptive to life on the ground. So disruptive that in 1973, the United States government, along with much of the world, banned all civilian aircraft from supersonic flight over land.
For the US, it's a speed limit.
The only civilian jet to ferry passengers faster than the speed of sound was the Concorde.
But it was only able to fly over the ocean, supersonic. So you could do London to New York, but you had to slow down before you got to New York and be subsonic. So the routes were very limited.
The Concorde was a celebrated technical achievement and an exclusive luxury for its passengers. Limited routes and heavy fuel consumption meant that operating the Concorde was not good business, however. It stopped flying in 2003. But if supersonic airplanes could fly over land, they can fly anywhere. And the business proposition changes. NASA and Lockheed Martin are hoping this crazy-looking airplane is a step in that direction.
It's designed to go supersonic without making the loud sonic boom that we've been accustomed to hearing for decades now.
To understand how this might work, it's important to understand how a sonic boom happens.
Just like a boat. When the boat is moving, you get the wake coming off of it, and it is with it the entire time it's traveling. Similarly for a supersonic aircraft, the shock waves come off the aircraft and travel to the ground the entire time it's flying supersonic.
So, when engineers designed the X-59, they used smooth and long aerodynamic lines to limit those shock waves from reaching the ground.
The engine is above the wing, and that's so that the shock wave from the engine isn't able to go down to the ground, it just goes up.
It is still audible, like a quiet thump. And most people, if they hear it, won't even notice it.
Something that would kind of blend into your everyday life.
The X-59's long nose is almost a third of its total length, and its sleek profile necessitated the elimination of a front windshield.
Looking at the front of the airplane, the pilot can't see anything naturally and relies completely on a system called XVS, or the External Vision System, which was developed by NASA. It's a new technology that uses ultra-high definition cameras and monitors to give the pilot a view out the front.
NASA is aiming for a first test flight of the X-59 in the spring of 2024. Poetically, over the same patch of California desert where Chuck Yeager first broke the sound barrier in the X-1.
NASA can take that data and then be able to present that to the regulatory authorities to actually repeal the overland supersonic limitations or laws that we have today.
A change in regulation could lead to a surge of investment in the next generation of commercial supersonic aircraft, making travel faster than the speed of sound more accessible to everyone. And that could send massive shockwaves through the air travel industry. Shockwaves that NASA and Lockheed Martin hope will sound more like a thump.